So anyway, the bottom line is I got the two pairs confused. And
Yeah, okay. Oh, as
I
in
got,
you actually got them confused. Like you didn't get them
I,
audibly
I
confused.
couldn't remember which pair was which. It's a little
The ultimate
embarrassing.
blind test. No labeling.
And hello, welcome to Not an Audiophile. I'm Andrew Hutchison, and today we speak with the assistance of Brad Serhan to Matthew Bond, the founder of Taralab Cables. We've spoken to him before. He mentioned in the previous interview that he'd done a lot of experiments with various cable configurations, and today he discusses more of those and how they worked out. Hello, Matthew. How are you going?
Andrew, I'm doing well. How are you?
Yeah, great. And you're sounding good. Sound quality's great. The amazing modern technology. It's quite convenient, isn't it? So much better than getting on a plane to do an interview like this. Hey, last time we spoke, we talked a little bit about, at some length perhaps, about the history of Tara Labs and some of the technology that you had experimented with and developed that got the world interested in your cables, and you had to move to the US and start this amazing business from there, and it grew almost exponentially, I guess. And but we did cover some of the tech behind it, but I believe you've got a number of other technical related subjects that you'd like to cover today. And I've got a question as well about something that I heard on the internet, on a podcast actually, and it sounded a bit kooky, really. But I'll come back to that because I've got to form the idea in my head because it was quite complicated and a bit strange. But we'll come back to that. So, and Brad, have you got questions for Matthew today along the lines of cable technology?
Yes, I do, Andrew. I'll have a couple of questions as we proceed through the...
Sounds a little bit like an inquest today, doesn't it? It sounds very...
It does, doesn't it? or some sort of police thing,
As if someone's done something wrong. There's a weight in the air, and it's because we know Matthew is going to expose some flaws in perhaps some marketing arrangements of some cable brands, perhaps. I don't know. He didn't say that, but I suspect that something like that is going to happen. Matthew, fire away. You've got thoughts. Tell us all about them.
Oh, okay, if you just want me to get into it.
Yeah, get into it.
I do have thoughts. What I'd probably like to start with is something that I call the nines competition, which is a question of copper purity in a conductor.
Mm-hmm.
Sometime about 30 or 35 years ago, Hitachi published a research paper with photographs of their engineers, and they said that they claimed they had created 6 nines copper, 99.9999%
Mm-hmm.
pure copper. I've heard 6 nines copper, and I do believe it's better.
Yeah.
But I have real doubts about how it's made because copper purity is a process of electrolysis. And
Okay.
I can imagine how if you had a fine conductor and you were putting it in a bath of liquid and doing the process of electrolysis and the anode drawing impurities from the copper.
Mm-hmm.
But if you get a large conductor and even a block, an ingot of copper, I see that the impurities can only be drawn from the skin, the surface of the block or the ingot or the conductor.
Well, yeah, that makes complete sense, yeah.
So that's one thing. I don't know if you have any comments about that, but that's the first thing, the nines competition. And, 8 nines, for example, I've heard a ribbon cable company claim that they've got 8 nines copper. And I doubt that's really possible. I think these kind of claims should be supported by an assay certification.
Mm.
Right.
I think if you're going to publish this kind of stuff on your website, the material, the copper or the silver that you're using needs to be assayed. That would be my point.
Yeah, no, I have to say, I've really not thought about the chemical process of purifying copper. I guess I kind of thought it was something that happened more during the like the mining phase or something, where you're digging it out of the ground, and I guess you're separating it from the gunk that it was involved with. But I have no idea. It's not something that I have stripped a lot of cable. I've soldered a lot of copper wire. I've never thought about where it really came from. So I'm going to have to leave that one to you, Matthew, unless Brad has got some insight, because he's part-time chemist.
Yeah, in my dreams. But the interesting point that Matt made is that the 6N. Do you have doubts about the 6N, Matt, in terms of the way Hitachi did it?
Yes. I mean, there's a lot of claims in the cable industry.
Sure.
And I don't think I don't think most of them are true.
You heard it here first. There's a suggestion.
It feels like an episode of Mythbusters.
A suggestion for a second.
Mythbusters.
I don't know. I think for many of our listeners, the concept that claims from cable companies may not be completely true might not come as a shock. Maybe it will. I reckon you've got others, Matthew. You're doubting copper purity, but you're probably...
Although, sorry to interrupt, Andrew. Yeah. When you say doubting the purity of, say, the 6N, have you listened to the difference between 4N, 5N, 6N? Have you claimed 4N to 6N? Have you heard that difference?
I've heard a difference between ordinary copper, 2 nines and 4 nines, and I have listened to 6 nines. I do think it's better. There's a lack of harshness in the sound. There's no doubt in my mind about that. But I question the process that they claim to have arrived at the purity.
Oh, okay.
It's not the only questionable technology. There's Ono continuous casting, where you've got a block of copper going through a die which is heated to about 1,000 degrees Celsius. I think that's about right. 1,064, some number like that, is the melting point of copper. So they take molten copper and extrude an ingot, a small round 1 centimeter in diameter by about 6 centimeters long. They extrude this rod, and this rod is then sold to wire drawing. I'll explain that in a moment. Wire drawing facilities.
Right.
And you've got this hyper pure, long crystal without crystal junctions, which we're going to get to in a minute as well. The idea being that with this pure copper rod, it passes through, when I say the idea, the fact is it passes through a progressively smaller hole through something called a die. So let's say the rod is 1 centimeter or 10 millimeters in diameter. Then it would pass or be drawn through, pulled through a die with an opening of 9 millimeters, 8 millimeters, then next 7, 6, 5, 4, 3, 2, 1 until you get down to 1 millimeter. And That is how 1 millimeter wire is made.
Yeah.
Right.
Okay.
The problem I have is that they claim that they have a single crystal longer than 100 meters.
Right.
Yeah, that seems. I mean, is that the claim, Matthew, of some?
That's the claim. You can look it up. I decided I had to look into this, and so I did some Googling.
Okay.
So 123 meters or some number like that. So then you've got to realize that the copper conductor at 1 millimeter has to be spooled. It can't be pulled for 100 meters and left to dry or left to sit there.
Yeah, well, that's right.
Right.
So it gets spooled, and somebody's going to say, "Well, how big a spool is it? Maybe it's a 1 meter in diameter spool."
Okay.
They're not. I've been in dozens of times. I've been in cable making facilities or factories.
Yeah.
So a typical spool is about 30 centimeters in diameter.
Yeah.
So with that, you're going to have crystals or breakages of the crystal, and you will form crystal junctions in the copper that's being rolled onto the spool.
Yeah. Clearly. I mean,
So any bending of the cable will affect the monocrystal or
Yes, it will.
break it. Okay.
Yes. This much I know.
And also, Matthew, I suppose Ono continuous castings, the old OCC for those.
Yes.
Yeah. Copper.
So there is that.
Have you heard a difference with that, the OCC?
OCC?
No, I haven't. I haven't spent much time listening to OCC.
What is OCC
So,
for? That's the single crystal.
The Ono
Ono
continuous
continuous
casting. Yeah, okay, yeah. Not to be confused with OFC as in oxygen-free copper or whatever.
Right.
Which I guess is any copper, isn't it? I mean, if it's any kind of purity, it doesn't have oxygen in it. Is that just while we're on that? Because it's not a high-end marketing term, but OFC copper gets thrown around and has done for a long time. Is it? It's simply. I mean, that's just copper, isn't it, Matthew?
Well, there's something primitive in copper called tough pitch copper, and that's the kind of copper that you would buy as inductors or transformers. Magnet wire is what it's called in the United States.
Yeah, okay.
So,
so your standard. So just to cut you off for a second, so your standard, we call it in Australia like winding wire. It's something like a transformer maker or a motor rewinder would use, like just your standard enamelled copper wire, which comes in all sorts of different diameters. So that's not particularly great quality copper. Just for clarity, that's not.
It's a good but standard copper.
Okay. So not oxygen free.
OFHC is the next step up, oxygen-free high conductivity.
Okay.
And that's truly about 4/9 pure.
Yeah, radio. Oh. Okay.
And in your inductors, you're probably getting OFHC. That would be my guess.
Yeah, okay.
I don't think you're dealing with tough pitch copper when they're making winding wire.
Right, okay. So it's pretty good quality copper then?
Yes, it is.
Yeah, okay. And what was the other little marketing tool that some cable makers use that annoys you?
There are things like, we just briefly touched on it, conductor crystal structure.
Mm-hmm.
And what I think about is theory versus reality. What can we hear?
Right.
And in crystal structure, you've got the idea, the claim, that the crystals act like diodes, rectifying the signal current.
Yeah.
And we're talking about a fine crack that can only be picked up by a microscope. And you may say, well, the current is as small as the atomic structure.
Mm-hmm.
But it's powerful enough that it obviously goes through crystal structure and crystal structures don't inhibit current flow.
Right.
Sorry, my eyes glazed over just for a second. I'm just wiping them back. So the this is probably well above my level of expertise as far as which is meant to be, of course, and that's why we've got you here, Matthew, because you know all this and I know nothing. But it's I guess I as someone I mean I enjoy the improvement that good cables make in all areas of a system, but sometimes the minutiae of the subject is it's what's the word?
Overwhelming?
Yeah, overwhelming, and at the same time, are there other aspects of the system that we could concentrate on that would improve the sound quality somewhat more dramatically? And I think this crystal juncture thing is something that I don't know. There was something I wanted to. Something you just said prompted directional cables. I want to jump sideways. I cannot remember, but I think they did. Your Tara Lab cables, the ones that I might have sold in the I guess the early to mid 90s or something, or sometime in the 90s, were they directional? And if they were, please explain why. And if they weren't, explain equally why they weren't. Or because the directional thing is kind of now that's I guess to do with crystal structure of the copper. Is that the thought?
No, not really.
Okay.
But
All right.
no, they're two different phenomena. But let's talk about cable directionality. It's a big boondoggle. It's a big one. The bottom line is it's bullshit.
Just once again to cut to the chase. Newsflash: directional cables are bullshit.
Yeah, but there's an exception to the rule.
Oh.
So I want to start with the conductor.
Okay.
If you play the conductor, we're going to set up a simple speaker cable, 18 gauge, about 1 meter in length. We're going to have a positive run and a negative run spaced apart about 5 or 6 millimeters.
Yep.
Right.
And so we do that with sticky tape and matchsticks, maybe.
All the good,
So
it's
it's
stuff.
naked. It's a naked.
So it's naked wire.
Yep.
So here's the thing. That doesn't have any directionality at all. Back and forth, back and forth. I've heard it. The conductors themselves don't have directionality.
Okay.
So when you hear about, the conductor directionality has to do with the way it's drawn in the drawing process into the finished conductor.
Mm-hmm.
So you have to be careful which way you turn the conductor or have them set up. So this is bogus.
Okay.
And I have gone to the trouble of making up wires and conductors to test whether there is any directional nature in wires.
Quick point,
So that's
Matthew,
where it
just
ends.
A quick point. So if you were to just with the naked conductors and just play music the same direction all day for a week, and then change the direction of the actual conductor naked, so it won't sound any different.
It doesn't.
Correct. Okay. So what happens when does directionality actually apply in any form?
When we build up the cable, putting primary insulation or dielectric on the conductors, and then we build up the cable with more layers of dielectric or plastic materials, you get the electrostatic charges within the layers of the plastic materials. And additionally, the electromagnetic wave, the signal current, the audio signal, has to find its way through these insulators. And the more insulation cable buildup that you have, the thicker the cable, the worse it gets. And that is directional.
Okay.
Oh.
So, so the wire itself, the copper, is not directional because, I think you're right, Matthew. I've read where the way it's pulled or pushed through the die is the reason, and the crystal structure is the reason why this cable's directional. That in your opinion, and you would consider it to be a fact, and I like that. I like facts. Is BS. But once you create a finished cable, the dielectric starts to play a role. But can you just throw some light? You've said because the signal is coming out through the dielectric to some degree, some leakage
Right.
or what have you. I guess it's on a humid day it's drawn to earth or something. I don't know. But the point is that to some small degree that happens. But why does it become directional? Is it the way the particular inductors are insulated differently, or I'm struggling to understand how it would still be directional, assuming. Well, you explain your thoughts, please, because I think that's very interesting.
Sure. Something to do with the valence bonds in the polymer causes the dielectric material to have different electrostatic charges.
Okay.
In the dielectric material, you've got different, what is termed today as dielectric permittivity, which used to be called dielectric constant, and sometimes still dielectric constant is used and understood by those in the know to be the same as dielectric permittivity.
Okay.
So what happens here, I like to think of it as absorption. In some cases, a dielectric material may be more prone because of the quality, and we move up the ladder from PVC to polyethylene to polypropylene to Teflon or polytetrafluoroethylene, to be precise.
Yeah.
And these materials have different rates of absorption and release of energy. It's a capacitive phenomenon.
Yeah. Yep. Makes
and
sense.
It's not unlike a capacitor.
Yep.
So that if you have poor quality dielectric between the plates in the capacitors, then the capacitor the capacitor has less strength between the plates, and so it's not a good quality capacitor. It sounds bad, as you guys have experienced, I'm sure. There's also the case that when you put in a new capacitor, more especially in an AC coupled preamplifier or line stage preamplifier, the capacitors take minutes to hours, depending on the charge, the voltage and current being applied. The capacitors will change their sound from minutes to hours. And you may have experienced that in loudspeaker design. So the same is true for cables. That is the reason for cable burn-in.
Yeah. Okay, so here we go. Okay, so cable burn-in has got more to do with the insulation and the dielectric than it does the wire?
Definitely.
Okay. All right, interesting. We're learning stuff here today, Brad. I don't know about you.
Well, definitely.
Yeah,
definitely.
I guess. Yeah. Yeah. Bloody hell, Matthew, you're the guru. So, okay, so that's interesting. Okay, because cable, I've got a few notes sitting here. Cable burn-in actually wasn't one of them, but it is one that I had in my head that I think, Brad, you mentioned you wanted to bring it up, but we're here, so why don't we talk about it? So cable burn-in, so you have I think you actually have a CD or a file you can download or something, Matthew, that you play, or tell us about that. What's the story?
That's the Cascade Noise burn-in disc.
Okay.
And I haven't thought about it for years, so I might get a couple of facts out of order here, or not say the right thing. I'm going to take it slowly.
Sure.
Cascade Noise is a compilation of square waves, sine waves, and percussive sounds overlaid over the square waves and sine waves on the disc. And this is, in the last 72 minutes long, this is the best way to burn in or break in audio components, loudspeakers, and especially cables.
Okay.
So I sell it, and people find it remarkable. I've got some people saying crazy things which I don't believe, and that is that they play it before they sit down and listen to any serious music listening session.
To break their ears in?
I wonder. No,
Yeah, yeah.
no. They say that they will let it play for an hour before they come into the room, so that the system is fully exercised or broken in. However,
Yeah.
I think it takes hours or days to break in a system, maybe weeks, and I find that systems just over a period of time get better sounding all the time.
Yeah, I Brad will have strong thoughts on this. I absolutely agree. I have had circumstances where I have just been gobsmacked and wondered what is going on. And I've just remembered one circumstance where I had a pair of loudspeakers that were kind of run in, quite an exotic pair, nothing crazy, but $10,000 or $15,000 worth, and they sounded great. The customer loved the sound. They bought the loudspeakers. I packed them up. I lay them on their back inside their box. I packed them up. I put them in the back of the van. I drove to the job, which was a good way away. I think about 2.5 hours away. I got them out at their end. I plugged them in, and you know what I'm going to say? They just sounded awful in every way. Now, there's lots of things at play here. There's one that I've been sitting in a van for 2.5 hours, and maybe that hasn't actually done my hearing any good. It would be the first thought. But I think you can hear past a lot of that. I mean, you sort of, your ear-brain interface, adjusts automatically for a lot of stuff. And I've got lots of thoughts on this. To do with hi-fi shows and things and how sound varies from room to room and why and blah, 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 blah. Anyhow, the point is, but the guy, the customer, loved the sound. He goes, oh, they sound amazing. They sound just like they did at your shop. And I'm like, geez, not to me they don't. So maybe that points to the fact that I'd ruined my hearing 2.5 hours in a van, which then brings us back to the run-in disc. And of course, I thought initially you were suggesting the client who bought your CD was listening to the run-in disc, but they actually just had it playing on the system.
I do have a funny story to tell you, but I'll wait. Okay.
Well, I think I'd finish mine. The point is that there are mysteries in why the sound changes. And the other thing you say about it, the system keeps getting better, and I think everyone who's ever done a hi-fi show, exhibited at a hi-fi show, feels that their system is sounding at the best on the third day. But is it, have you just gotten used to it? Or has indeed everything warmed up, loosened up, settled. Got used to the local atmospheric pressure and humidity? I don't know. Anyhow,
so many factors. Plus the stress.
The stress, yeah. You're obviously more relaxed on the Sunday.
The Thursday setup is fraught with anxiety that the room's not right, everything's not right, and there's a sort of stress sweat that sort of, actually, the interesting thing about stress sweat, Andrew and Matthew, and you guys probably, I don't know whether you used it. I used to use a eau de cologne back in the day called Desperation, and it didn't work then. And I smell it every time I do a first day show set up, and I smell that eau de cologne coming to the fore, and it's just fear.
I think that's I have seen you going through that, and I think that is mostly created in your mind.
But Andrew, in all seriousness,
yep.
The point you make is that the first day you've got to get assist. We are going off at a tangent, but the first day you're coming to terms with the room,
yes.
The sound of the room. You're used to your own listening room, etc., or the hi-fi shops. You might go and listen to that, and then having to adapt to the sound of that room. Your brain's sort of getting used to it, and then you go through the process of getting the system set up and the position of the loudspeakers where you think it works best, and then you get to that point where, Matthew, you've done quite a few shows, obviously, where it starts to sound okay. And to your point, Andrew, that by the sort of Saturday afternoon, you're starting to sort of, reduce the caffeine intake, and you're starting to sort of enjoy chamomile, and the system settles, and people seem to generally like what's going on. Don't forget, every other poor exhibitor is going through the same thing as well. By Sunday afternoon, you wish you could just go into Monday, in a crazy sense.
I know.
So
I
does
was
the
going to ask.
Well, there's
go ahead.
I was going to ask you guys, because you do so many shows. What is it like on the end of the show? At the end of the show, on the pack up day, the system sounds great, right? And you got to tear it apart.
well, I've got
Yeah.
one. Yeah, I've got one brief look or thought on that, and or fact, and that is that at the last show we're in a different room in that hotel than previous, and we didn't feel acoustically it was as nice, even though we had the same acoustic treatments and same well, not the same loudspeakers, a newer model, but we just weren't. No one there thought that the loudspeaker sounded as good as they had in different rooms. So we went to some trouble to trick up the room acoustics with a bit of extra absorption in a couple of corners and things like that. And kind of forgot about. We felt that had improved it at the time, but it was partly acoustic, maybe partly psychoacoustic. But then when we started pulling the room apart on the Sunday afternoon, we just started pulling some of these acoustic treatments down first while the system was still playing, and oh wow, we weren't even thinking about the sound. We were well past playing music at that point. There was a few stragglers coming in, and that's why the system was going. And my God, it was hugely obvious to everyone that the sound was becoming much more reverberant, ragged sounding, and less enjoyable as we pulled our bodgy extra acoustic treatments out of that we'd used hotel furniture to achieve out of the corners and what have you. And so there is absolutely something in it. Of course, I mean, everyone would agree that there's something in the acoustic treatment side of it, but it was much bigger than you would think. But yeah, look, getting fully wound back to the start.
Andrew,
sorry.
Sorry to interrupt, Andrew. The point being that going back to Matthew regarding a system settling in.
Yes.
Yeah. Is it bunkum that cables settle in, just being left alone, settle over 2 or 3 days, in your opinion, Matt? Or is that a hard one to answer where everything's sort of settled?
No, I think a couple of points I would make about setting up a system and using cables. Try to use cables that have the least amount of construction in them. The conductor or the conductors are the most important fact in the design of a cable.
Right.
The next most important thing is the geometry or the spacing of the conductors. That's like tuning the response, the high frequency response of the conductors.
Right.
Obviously, you start out with what I call an optimum diameter, no bigger than 1 millimeter in diameter.
Right.
And then the conductors need to be insulated, of course, and the insulation should be high quality and thin layering of dielectric, nothing greater than a few to 0.5 of a millimeter.
Mm-hmm.
And then the amount of plastic that is in the construction of the cable will absolutely just make the sound soggy and rolled off. And this is when you've got the cable burned in. If you turn it around, this well built up cable built up with polymers, plastics, etc., maybe you've got cotton ropes in there. They're the worst.
Mm-hmm.
So if you turn that cable around, both left and right channels, you turn them around, the cables are unlistenable. Okay. So the fact is that burn-in makes a difference, but is less of a problem when you've got good quality, well-built, well-designed cables.
Okay. All right.
And all of the things that we've been talking about, the nines competition, Ono continuous casting, crystal structure, all of these things matter when you've got the conductors not left and right, positive and negative, when you've got them set up with a decent spacing between them so you lower the capacitance. If again, we touched on this in the last podcast, if you were to make a twisted pair an interconnect with a twisted pair of 1 millimeter conductors nicely insulated, and then you compared them to a pair of conductors that were spaced apart 5 millimeters, you would be able to hear the 6/9s and the Ono continuous casting and the lack of crystal structure in the conductors. But when you've got a twisted pair with high capacitance, you roll off all of the benefits that you work so hard to create.
Yeah, okay. Yeah, that kind of makes sense.
Okay, so may I just make a point? So I just want to go back to your points there. So the nines competition, you feel subjectively you found that, well, it has to be subjectively, that there's an improvement with 4N to 6N?
Yes.
Tick?
There's merit in all of these technologies, but the way cables are made, they ruin the improvements that are brought by these technologies.
Right. So if it's the configuration is important, the way you lay the cable.
Very important. So if you see a cable and you notice that it's got a plastic jacket on it, a polymer jacket on it, and the build-up around the conductors because you've got a cross-section of the cable, the diagram, or you've got a piece of it, if you see a lot of plastic, it's going to sound like shit.
Okay, interesting. And the OCC, that again, in OCC and the crystal structure, there's definitely, you've heard differences there.
I have, but what I said earlier still holds. There's doubt in my mind as to how it's done and whether the final result can really be valid.
Okay.
All right. So,
I mean, there's another one, ceramic dyes. I don't know if you've heard of this, but Kyocera in Japan makes ceramic dyes.
Yeah.
So you've got small holes in the center of the die. The wire is drawn through. The idea is that instead of using a metal die, you use a ceramic die so that fine metal particles don't get dragged into the surface of the copper conductor.
Oh, yeah.
But copper is soft, and metal dyes don't wear out. Not
Yep.
So what you're saying is that the copper's molten when it goes through this.
no, it's not molten. It's
cold
room
drawn,
temperature.
yeah.
Oh, okay.
So it gets pulled progressively through smaller and smaller dyes. And
Right.
if they're metal dyes, of course, they're not getting worn out and having to be replaced every 1 kilometer of wire is drawn.
No, they last for some considerable time. You're implying, Matthew.
Of course they do.
Yeah,
Yes.
yeah. Okay, so we're gonna have a quick break. I want to come back and ask about cable lifters, Litz
Yes.
wire, cryo treatment,
Good.
and there's something else, and I can't think. You just touched on it, I think.
Is it not sexual annealing? No, it's annealing, not healing.
Sexual annealing. Brad did again.
Funny, Brad. It's annealing.
Attempting humour. We'll be back in a second. Thank you, guys. Talk soon. Thank you, everybody, for listening to the podcast. It's really appreciated. And even more appreciated is comments, likes, 5-star reviews, that kind of thing. It's also very much appreciated. So if you're enjoying the podcast, please subscribe, follow, like, and comment. All right, folks, we're back. Not an audio file. Segment 2 of today's podcast with Matthew Bond of the Cable Guru, and as we're now calling him, and Brad Serhan, of course, the loudspeaker design guru. So, room full of gurus. I want to say three rooms. We're all in different parts of the world. But so, Matthew, you're okay. You didn't need a break just now.
No, I'm fine. I've got my diapers on again.
I'm sure that's
wow.
incredibly inappropriate.
So smart. So smart.
But yeah,
I'm ready for a space mission.
He's a planner. I didn't have a break, so I'm having a drink now. So so I mentioned Look, I've got to ask. I want to go skip ahead, and I just need to know about cable lifters. I have strong feelings on them. I think they are the silliest, stupidest, most ridiculous piece of hi-fi bullshit there is. I know why people do it, because the cables look kind of prettier sitting up in the air, like some kind of monorail of electricity. But I guess all monorails have electricity in them. But I just find it hilarious. And then they've got to be made out of particular materials because the other ones are no good. So Matthew, feel free to educate me and turn my thoughts on these contraptions to a positive one.
All right. We touched upon already the plastic buildup, the polymers in the cable and the jackets.
Okay.
Versus a simple construction where you can judge that the cable is not complex and isn't round in a jacket with a twisted pair of conductors, insulated conductors running in the middle of the cable.
Mm-hmm.
These kinds of cables have electrostatic charges in them.
Yeah.
And that is something that can be picked up by nylon carpet on the floor, and the cable lifters work, in my opinion, not on wooden floors, but they would work, it seems to me, on where
Carpet.
you've got carpet on the floors.
Yeah, okay.
But I'll be honest
Right.
with you, Andrew, I haven't sat down and listened to cable lifters.
Okay, yeah, but so you think that the electrostatic aspect of it with carpet might be a thing, but which makes sense based on your previous thoughts on the whole electrostatic nature of different insulation materials, etc. But what so I hear though that most people are using cable lifters because it's something to do with vibration in the floor or something, which also there's a slight ring of at least a story there, which is that I guess the loudspeakers are feeding a certain amount of vibration into the floor, and if the floor is, I guess, flimsily constructed or something, or resonating at some frequency, which of course it would be, that's what the lifters are about. They're there to isolate the cable from that. Have you got any thoughts on that, or is your interest in lifters at a fairly low ebb?
No, I want to talk about what you've been talking about. We would have to assume that the cables are so poorly made that they are microphonic.
Yeah, well,
yes,
so
right.
that would mean that they were poorly made. If they were microphonic, I guess it would be, wouldn't it?
Yeah.
Okay.
Can I lob my two bobs worth in?
Yes, you can, of course.
The sort of in the past, I used to take that similar stance to you, Andrew. But dare I drop a bomb?
I don't want
no, not a bomb. Les Davis is a bomb, but my dear mate Les Davis from Les Davis Audio, he has some devices that which can be used underneath cables, and we've done quite a few listening tests with those underneath certain cables, not Matthew Bond cables, and yes, on carpet.
Yeah.
And it seemed to improve the sound in a sort of seemed to sort of make things cleaner. Now, this is us doing, listening test, blind test, or whatever, swapping down at Sturman's Audio. So interesting stuff. So to Matthew's point about the nylon carpets, etc., how they might interact with cables. Because with nylons rubbing up against some sort of plastic, I assume there'd be some interaction, or maybe not. That's just throwing that in there.
Yeah, and then there might be something else going on. When you have two dissimilar materials in the construction of a cable, you can get what's called triboelectric noise.
Oh, right.
And this is a noise generated by, as I mentioned, two dissimilar materials rubbing together, creating an electrical charge.
Right.
But again, that's a poorly made cable.
Yeah.
Right. So it could vary depending on the quality of the construction of the cable, design of the
Yes.
cable. Okay. Anyway, I was just throwing that in there because I have
Very
heard,
interesting, Brad. Yeah, I haven't heard
differences, and it was there's a difference, and we thought there was an improvement. That was without Les in the room as well. So, well, you have to take into account that if you've got someone there that you know, and that you know well,
yes,
and you've got to take into account how our brains work and influence. So,
well, you absolutely do, and with all of these subjective, even if they're blind, and if they're genuinely blind, then a genuine blind test, and you can pick it, then it's absolutely, and if you consider it's an improvement, then it's absolutely a real thing.
Well, it's real this week. I mean, if we had Alan March here,
well, he would say
but it could be good.
I'm channeling Alan.
That's what. Because Alan is a very brilliant engineer. So.
Well, he takes a very scientific approach. So, and which is probably the correct one. But as I always say, I counter my own thoughts by saying I don't really care, because if the listener, if the owner of the system is trying something and it works for them and they're enjoying it, go your hardest. I mean, I don't care. My thoughts are simply my own and are to do more perhaps with my priorities in life than whether I...
Yes, and that makes sense, Andrew. Absolute sense.
Yeah, I've just got other things I might want to do. I go for a walk on the beach instead of playing with cable lifters is, to me, somewhat
and make
more
it look like a really good train set.
Yeah. Let's not get
it. All aboard.
So no one on this podcast owns a train set, I take it?
No.
Hornby? Oh, yes.
Well,
back in the day.
Oh, really?
No, back when I was about 7 or 8.
Oh, okay. That's all right. Acceptable. Okay, so on a recent podcast, and I wouldn't call them an opposition podcast, I would call it one of the leading hi-fi related podcasts on the planet, there was a guest on there extolling the virtues of a cable, Matthew, that could both increase the transient performance of the system. He suggested this was due to less impedance, perhaps. And he also implied that differing cables have a different time signature or a different impulse response. Have you got any thoughts on cables and whether some cables are literally faster or slower than others?
The velocity of propagation of the audio signal. It doesn't vary much at all in all audio cables. Additionally, as to cables having different impedances, I would say that's true, but it's a microscopic or very small number.
Sure.
The thing that, again, the things that make the biggest difference, or the real differences that can be proven easily in A/B listening situations, is the size of the conductor. It's the predominant factor in cable design. If you would have, I think I already mentioned this, if you had 6.9s, if you had OCC, you used ceramic dies, and you had long crystals.
Continuous crystals,
Yeah, but you made the conductor 1.5 millimeters in diameter, you've lost all of the things that you tried to create.
Yeah.
So if a cable has a particular impedance or a particular velocity of propagation, it's certainly not going to improve the sound of the system. That's an outrageous claim.
Yeah. So, because you want it to be, well, you want the cable to be, you have no signature really, and have...
Well, you want it to have, I mean, if possible, well, let's talk about impedance for a moment. Inductive reactance, capacitive reactance, which are we talking about? In a speaker cable, we would be talking about inductive reactance.
Yeah.
Inductance. Getting that figure as low as possible is the key.
Yeah.
So, and then the speaker cables that I make now, inductance is extremely low. And the sound of my cables, I would not go as far as saying improves the whole system. They improve the sound.
Yeah, yeah.
But, making a preamplifier function better or a power amplifier suddenly has more power, that would be outrageous.
So this was a headphone cable. It's going to sell for €1,250 for a 1.5 meter cable to put on your headphones. It's a Litz cable with maybe 200 conductors per conductor, per strand, per polarity. So there's two lots of 200, I think, or thereabouts. You got any thoughts on Litz cable? I guess in this case, if it's headphones, it's a high impedance, low current situation. It's not a speaker cable, so I guess different characteristics. Perhaps.
Yeah, different. Litz wire is not good. The premise of Litz wire is that each strand is insulated, and it's not a simple bundled conductor of raw uninsulated strands.
Indeed, yeah.
But if you've got a Litz wire conductor and it's greater in diameter than 1 millimeter, it rolls off high frequencies.
Yeah.
Once you individually insulate the conductors and bunch them together again, there's no audible or measurable improvement in the roll off of high frequencies. It actually becomes worse. A 3 millimeter diameter Litz wire sounds bad. A 2 millimeter diameter Litz wire sounds bad. When you get down to 1 millimeter and it's Litz, it will sound good, but not better necessarily than a solid core conductor at 1 millimeter.
So it's a lot of extra effort from your implying no benefit.
No benefit at all.
Yeah, okay. I guess other than greater flexibility of the wire itself.
Yes.
Yeah. What was the other thing I was going to say?
Cryogenics.
Cryo, yeah.
So you know the story here. The claim is that they take the cable or the conductor, whatever it is, and they take it down to somewhere near 0 degrees Kelvin.
Yeah.
Which, as I've been corrected, is minus 273.15 Celsius.
Yep.
Thought I'd throw that in there, the 1.5 for you, Andrew.
Yeah, the one.
You guys corrected me in the last podcast.
The 1.5 is well, let's face it. If you don't make it, was it 273.15?
Yes, 273.15. I think I read.
I'm guessing because it's a negative number. If you only get to 273, you haven't gone far enough.
No,
and the
cryogenic. It's warm by comparison.
Yeah, it's warm.
What did you say, Andrew? Matthew?
I said 273 is warm by comparison. and 270 is sweltering.
Yeah,
well, you'll take any degree you can get if you're if you're in that environment. So tell us about cryo. What's it meant to do? I thought it was something to do with crystal structure or something again, but I probably didn't take any notice.
You got it, Andrew.
Got it? Okay.
So we're going to take the material down to 260, 270 degrees, and then they say that it will be stepped up in intervals, going up to, say, minus 200 and then minus 150 and then minus 100, minus 50, ultimately to room temperature again.
Okay.
This sounds like diving. Diving underwater.
It is like that. Yeah. The thing is, there are many cable companies that claim they're doing cryogenics and that they have a proprietary stepping up of the temperatures that they have found makes the product sound better.
Okay.
So there's that claim, which again is just bogus. And I've got a funny story to tell.
Far away.
I was bugged every week with a phone call from somebody who had a cryogenic chamber and wanted me to send a pair of interconnects So I got 2 pairs of interconnects made, put them in the sound room, sent 1 pair off to be cryogenically treated, got it back about a month later.
Well, it took a
It
while
takes
for
that
them to
long.
warm up again.
It's the Benz treatment. They do the Benz technique.
Well, I specified 1 degree per hour.
Just
So
to mess with them.
I'm just kidding, but anyway, I got them back, and it took a long time to get them back, and I had them in my sound room. So I then picked up the first pair and the second pair, which had been cryogenically treated, listened to them, A-B'd them. I did AA, as we talked about in the last podcast, something I do to prove to myself that the second time round I hear differences and not audible and not acoustic differences, but that I notice different things from 1 30-second listening to the next 30-second listening test.
Yeah.
So anyway, the bottom line is I got the 2 pairs confused.
Yeah, okay. Oh, as in you actually got them confused, like you didn't get them audibly confused.
I couldn't remember which pair was which.
The ultimate blind test, no labeling.
So how did that work out?
So, they sounded the same.
Yeah, okay. That's
so
kind of nice.
Cryogenic treatments.
Oh dear. Yeah, I guess it's one of those things. It sounds kind of interesting and cool and a bit special. I mean, you could have, I don't know, I'd cryogenically treated all sorts of things, I guess. But yeah, it sounds great. So you've done the test. Admittedly, the 1 degree per hour raising of temperature, which I know you say was a gag, but that would have been. I mean, if you've got this guy hassling you with his cryogenic facility, and you go, "Yeah, I'll get it done, but only on the condition that you raise the temperature 1 degree an hour."
What was even better is they offered the Disneyland alternative as well.
Oh yeah,
the Disney one.
You could stow them away and bring them back to life years later.
Yeah. Boom. Yeah.
Any other thoughts on cable myths? I guess we're calling them myths because you've laid a lot of light on the ones that kind of work and how they could work. Then there's the cryogenics in your experience has not been effective. And
no.
But what else have you got, Matthew? Have you got any other little gems of information?
Let me think for a moment.
Can I lob in annealing?
Oh, yeah, we should lob in annealing, something that I know works.
Okay, all right, tell us about that then.
So there's something called resistance annealing, which is to say you take a length of copper wire, section by section, it goes into an ammonia chamber. The conductor is heated up, and it softens and becomes more conductive by eliminating crystal junctions, I suppose. Okay. I don't know why it becomes audibly superior, to be honest, but it's softer. You can bend it more easily. It takes more bending than a normal 1 millimeter conductor can, and I find it works. Annealing is something special.
Okay, so tell me, I'm a bit confused. So just set me straight. If you get a length of copper pipe that's not annealed, it is very stiff and very fragile. You can't bend it. It will tear, if you like. You then, if you've got to bend a pipe, and I'm no plumber, but maybe I've built a piece of equipment once that needed pipe bent, and so you get annealed copper, and you can bend it around a large piece of PVC pipe or something and make a very nice coil, which you might use in this said piece of equipment. But therefore, what kind of copper wire is not annealed? I felt like copper wire, because it's flexible mostly, although not house wiring. I mean, obviously that's quite stiff. But your 1 millimeter preferred conductors are annealed or not annealed?
They are annealed, yes.
Ah, well, okay. Well, kind of explains
and
that. Right?
they're coated in a material made in that originates in Japan called polyester mica,
Okay.
which is zero point zero 0.08 of a millimeter thick. So we're talking about an extremely fine film. They take they make mica powder, mix it with polyester, and extrude that over the copper conductor. So it's an inaudible dielectric material, the first one I've heard or haven't heard.
Okay.
Oh,
All right. And is this, okay, just I'll insert an ad here for you then, Matthew. Is this, some of these ideas are something you're using on your new range of cables? Or what?
Yes.
Oh, okay. All right.
Yeah, the short answer, yes. Using them on my, and the middle of from the bottom of the range through to the middle of the range and above, polyester mica is my preferred insulation material.
All right. Okay. Yeah,
okay.
You heard it here first. And you possibly did hear it here first, because this is all new stuff, isn't it?
Yes.
Yep. Okay. Brad, have you got anything else to add or anything you far away?
Thanks, Andrew.
The floor is yours.
It's interesting. Thank you, sir. And it's interesting how annealing and getting the sort of monocrystal with OCC. It's interesting that also cryogenic, which goes the opposite way.
Oh, yes, something I didn't...
So Matthew, I'm sort of thinking, well, okay, what's the so-called advantage of cryogenic treatment when it's supposed to give you a monocrystal or?
Yes, Brad. The claim is that you get monocrystals and that it's like they liken it to annealing, but I know annealing works, and my opinion is that cryogenics doesn't work.
Right, but heating the actual conductor helps and potentially helping with eliminating crystal junctions.
Yes, it heals the conductor, making, as I said, it more conductive and.
Yeah. Okay.
Oh, and this is measurable. This is not something that, and it's only a few percent in terms of conductivity, but it makes the difference between tough pitch or 4/9 copper to have 6/9 copper soft annealed.
Okay, right.
And I guess these extra processes are what adds a significant cost to an audio cable. Is that right, Matthew?
Yeah, that's right. I don't know the price at Bunnings for a 1 millimeter conductor. I've never been into a Bunnings. I was just told some time ago that was the equivalent of Home Depot here.
Yes, it is. Yes. And so,
one day I might get a job. Well, I'm going to retire back in Australia. I'm going to go work in. I'm going to go work in Bunnings in the wire department.
Wow. Well, actually, Andrew and Matt, there is in Sydney. There's the Turks Electrical Centre.
Yes.
A lot of Turks around the place, and you might be better at Turks where they've got like a whole lot of that electrical cable.
Okay.
And
I appreciate any suggestions you have, Brad. That's great.
I think my question is,
I'm
not sure my resume is going to help me.
Just put yourself down as a young Turk. They'll love that.
Uh-huh.
Oh,
yes,
okay.
Dear indeed. My question is, why would you move back to Australia, other than obviously the wonderful weather and the birds and the beaches and the...
I've got a little spot picked up on the Sunshine Coast.
Oh, no.
Beach. He's very close to you, Andrew. Ho, ho, ho.
Oh, yeah. Okay, the Sunshine Coast, eh? I'm very familiar with that wonderful part of the world, as I lived there for many years. What part of the Sunshine Coast, Matthew, have you got selected?
Moffat Beach near Caloundra.
Know it well. Okay. I mean, it is a wonderful part of the world. The only catch with the place is there's a whole bunch of other people that also think it's wonderful and choose to live there. So it's lost a little bit of its charm, perhaps, over the years as it's become more and more busy. When was the last? We're obviously changing subject, but when was the last time you were there, Matthew?
About 2 years ago.
Oh, okay. All right. Well, I don't think it's changed much in the last 2 years. So yeah. So yeah, that's interesting. Okay. So like, what can I say? I mean, it is beautiful part of the world, and the whole strip really is. I mean, the whole strip, southeast Queensland, probably from Byron Bay up to Wanton, is an amazing part of the world. So, but then you live in an amazing part of the world at the moment. So, but I guess you get bored with everything, right? So you have a hell of a winter there, I would guess, would you? Or is it just foggy and humid, but cooler?
It's mild.
Yeah.
The temperatures get cold down to 32 Fahrenheit, 0 degrees
Yeah, okay.
Celsius.
Yeah.
And we get some snow.
Okay. Yeah, all right. So
Right.
less of the fog and more of the snow. Yeah, well, there's certainly no fog or snow at Moffat Beach. So, but there are tourists. I feel like there was some other cable business that we had to discuss, but maybe it's done, in which case we can go on to general business. I have no idea what general business is, but if anyone's got anything to discuss, I'm happy to.
I think that you might call that sundries.
Sundries, indeed. So I had a sundry, but I didn't write it down, and now I've forgotten what the hell it was.
Well, okay, but while you're thinking of that, Andrew, I might just throw something at, well, not a question, but a summary, I suppose, of what we've been discussing, and it's essentially, Matthew, a lot of this stuff that not all you feel make a difference, but it comes down to the way you design the layout, the internal structure, if you like, of the wire and the insulation, etc. And a whole lot of stuff goes into the composition of a cable to the end user. This is poorly worded, but it'll do. You get my point, Matt.
The bottom line is that less is more.
Okay. And
that's probably true for loudspeaker design. I'm no loudspeaker designer, but I am sure that if I was building a loudspeaker, I would try to build it simply, and maybe some things are complex, like crossover design, filter networks, the choice of filters. I'm sure there's a lot to it. I have no idea.
Well, I think it's a little bit like cables in that the tiniest of the timber you use, how you treat it, the glues you use, the area of the material. Like we're just talking about cabinets. There's so many little There's so many little things that will affect the resonant nature of the cabinet and how it will react when vibrated upon, etc. Blah blah blah. It's a I don't know. It's a bit of it messes with your head. You know when you got it right though, because as you do with the cables, Matthew, it's magic happens. So, well, I think we seem to have wrapped that up, and I have a feeling, Matthew, we'd like to get you back at some point to discuss general audio stuff, because you've got a very interesting take on things, and I like your honesty, and I think the audience probably does as well, and I think also, as we mentioned in the previous episode you were on, you do have some new cables coming out that are fairly affordable, and I guess we might have you back to discuss those and drop a bit of an ad in the conversation, so that people know they exist and may want to give them a try at some point. So on that note, so feel free to sum up, Matthew and Brad, and we'll call that a take.
Well, I appreciate your time, Andrew, once again. I really enjoyed talking with you both.
Oh, it's been very illuminating. I just find I guess it's something that cables, you sort of listen to different ones or whatever, and you sort of gloss over what's actually in them, and you're thrown a light on what the construction actually is, and perhaps the ideal. Well, your experimentation has shown what the ideal way is to do it, and that you've shown off in your new models. But there's clearly a lot more to it than one would initially expect, and I found that very interesting. Brad probably knew it all already, but
oh no, I didn't.
You didn't?
No, I don't.
All right.
No,
so, all right.
I sort of had hints.
Yeah, okay.
A little bit, but that's only through Matthew chatting to me about it. So
okay.
No, I know bugger all. Like you, Andrew, I'm sort of fascinated as we went.
You probably got busy. You're busy with other things now. This podcast, not an audiophile, needs some love always from everyone who's listening. So if you've enjoyed today's illuminating episode, feel free, or would you please, maybe give us a 5-star review or write a little short essay, or like and subscribe, depending what platform you're listening
subscribe.
to. Yeah, well, it depends what platform you're on. I mean, we're on 3 or 4 different ways you can listen, and they need a different little different subscription or follow function. But the idea is to follow the podcast, and that way, when there's a new episode, you'll be.
What are we on?
You'll be
by the way,
we're on iTunes or Apple Podcasts. It's called these days. Spotify, YouTube are the 3 key ones, but also Amazon, Audible, and a bunch of other podcast aggregating websites have us listed. So we're everywhere, basically. So
that's wonderful, Andrew.
Yeah, no, it is. It's good. It's so far it's a new podcast, of course, but many people following and enjoying and giving us positive feedback. So that's very much appreciated, and we're happy to hear more. Comments, by the way, folks, are best made on YouTube, where you can just get on there and say whatever you want. And we'd be, positive or negative, we'd be keen to know what you think. So thank you, Matthew Bond from Tara Labs and Matthew Bond Audio, ex of Tara Labs, of course, and now of Matthew Bond Audio, and Brad Serhan of Serhan and Swift. Thank you for your input today and questions. And we'll talk to you all again, guys.
Okay, Andrew. Bye-bye.
Bye, Matthew.
Bye, Andrew. Marvellous stuff, mate. Thank you.
Thank you, Brad.